everyone, I'm Wan Lee. Okay, chapter 2, second lecture, marginal probability and the conditional probability. I defined or introduced sample space and probability on sample space. And also I introduced joint probability, which is defined over an sample space of, say, two experiments at the same time, because we encounter, okay, multiple experiment problem. That's why I just introduced joint probability of two outcomes. Okay, today, the marginal probability and the conditional probability is a subsequent concept of joint probability. Let's go. Here, marginal probability is when we have a joint probability, the probability related to one specific experiment is called marginal probability because it is written at the margins of the table like this. This is a margin, okay, of this table, uh, this three. I got an example of this kind of joint probability there. So probability of A is sum of all B's, okay? Notation is like this. Probability of B is like this, sum of all A of probability A and B. So let's see, it is not complicated, it is simple. Probability of 0, we want to get probability A equal to 0, okay? Then what is it? This is a point, sum of this row is a 0.2. Probability A equal to 1 is sum of this row 0.5, something like this, 0.3. And probability of B equal to 0 is what? Here, 0.1, sum of this column. Sum of this column will be 0.3, 0.45, 0.15. These are called marginal probability of A and B. Sum of marginal probability should be equal to 1. This one equal to 1. Sum of this equal to 1, right? Because it is a probability. Sum of probability should be equal to 1. Another thing is conditional probability. When outcome of experiment is given, one experiment is given, it refers to the probability of outcomes of another experiment. That is, when subset A of sample space S1 of one experiment is given, it is probability of a result subset from the sample space S2 of another experiment. It is expressed as like this. Okay? It is also a function. A is given, and what is the probability of some subset of another experiment? And the conditional probability satisfy the following conditions, like probability definition. For any subset B of S2, S2 is, say, second experiment, that conditional probability value should be greater than equal to 0, should not be negative value. This is a property of a probability. And A is given. A is what? Subset of S1 is given. Probability of S2 equal to 1, right? A is 1 given. Example, 1, this one is given. And what is the probability of B equal to 0? That should be 0.5 ratio of 0.01 divided by 0.5 divided by 0.5. A equal to 1 is 0.5. So what is B equal to 1? B is equal to 1 is here. So 0.1 over 0.5, something like this. What is the sum of this? Should be what? 1.0, because it is probability. Even conditional is restricted, but probability, sum of probability should be equal to 1, 0. All right. How to get conditional probability? When a subset A of a sample space S1 of one experiment A is given, okay, the conditional probability of a subset B from the sample space S2 of another experiment is calculated as follows. This is a basic formula. But why this result, this formula comes? It is a probability of both A and B occurring, say A intersection B divided by the probability of A occurring. This is because some of conditional probabilities must B must equal 1.0. You get it? Let's see it one more time. Okay, A equal to 1 is given here. Then we have to think about probability of B equal to 0, 1, 2, 3 in this section, in this restriction, in here, this area. And what conditional probability, sum of conditional probability should be equal to 1. So this value divided by 0.5, 0.1 divided by 0.5, 0.25 divided by 0.5, 0.1 divided by 0.5. So that sum of conditional probability equals 1.0, like this. Okay? All right. Let's see some more thing here. Okay, B is, A is 2 given. This one is given. What is the probability of B equal to 2? This one. So, what? The sum of this one is 0.3. In this area, in this section, what is the probability B equal to 1, 2, 3? So, sorry, 0.1 over 0.3, 1 over 3, right? What is B greater than equal to 2 given? What is the probability of A equal to 2? Probability B greater than equal to 2 is here. This is a restricted area. What is the sum of this probability? 0.6, right? 0.6, 0.3, yeah, 0.6. So in this area, A equal to 0 is a 0.1, 0.1, 0.6. A equal to 1. What is it? A equal to 1 here. So 0.35 over 0.6. And A equal to 2 here, 0.15 over 0.6. That's it. Support rate for candidate A in the region M. This is a conditional probability. Condition is region A. In region A, what is the support rate of candidate A? Woman's smoking rate. Woman is restricted, is what? Condition. And what is the smoking rate? Okay, probability of having hypertension among diabetes patients. So diabetes patients among, that is restricted, it is given probability of having hypertension. Note, probability we say usual is open conditional probability. We use conditional probability many times instead of just probability. See? All right. Another kind of conditional probability, it is Bayes probability. Bayes probability is the strange probability for the beginners. Okay, it is also referred to posterior probability. For example, smoking rate of a man is the ratio of a smoker given the condition of being male, which is commonly referred to conditional probability. However, in contrast, the probability that a smoker is male, okay, smoking is given. And what is the probability of a male? Okay, it is just some strange conditional probability. And the support rate for candidate A in region B, region M, okay, region M, is the conditional probability, as you know, but rather probability that if someone is a supporter of candidate A, the person resides in region M. Okay, Bayes probability refers to the probability of the cause corresponding to an event occurring after the event has taken place is called posterior probability. It is calculated as follows, like this. Given A, given B, okay, conditional probability of A is determined like this. You saw this formula, probability A intersection B over probability of given. Okay, B is given. Then that is it. The denominator is spread out like this. Probability B given A times probability A. Probability B given A complement. You know complement. Anyway, times probability A complement. Okay? Denominator. Like this. And numerator is probability B given A times probability A. And the same thing here. Okay, this one. So this is, I say, normal conditional probability. These are normal, normal means usual, conditional probability. Probability A is called prior probability. Anyway, you see example. Let's assume that ratio of man to woman among the customers of a cafe is equal. Ratio man to woman is the same. The smoking rate for men is 40%, and for women, smoking rate is 10%. What is the probability that a person who is smoking is female? It is a sort of a conditional probability, but looks, you know, strange. The given condition is probability of a male 0.5, probability of a female 0.5, male conditional probability smoking is 0.4, female smoking rate is 0.1. These are given in the problem. So therefore, probability of a smoker smoking given and the female is like this. Okay, so the result is 1/5, 1/5. Bayes probability is a main tool in Bayesian statistics, which is, popular in business school. I introduced the Bayes probability shortly here. No more. Okay, that's it today. Thank you. Bye.